Welcome to another video episode on my Arduino Mega2560 second series, where I started out with an investigation on how to deal with some electronics and an inductor using pulse modulation to get a back voltage and protection against it. Programmed in C, of course, because that is what an AVR, Arduino is programmed with usually. Apart from this, which doesn't yet really work, to my satisfaction that is, the second meaning of this is to get from the Octave program, which is mathematical high level programming language, scientific, to get access to the Arduino. And lately it hasn't been successful, to say the least, and I found some things that on my computer were not very accurate. Or maybe not. For instance, I did not have the latest supporting package for control, instrument control. And I also found that on Linux I could install Arduino IDE as well, while I usually use the up-to-date latest version of the Arduino IDE from Arduino, and there's a version difference. On Linux it is version 1.8.5 and Arduino releases 1.8.7. But that may be that the Linux version 1.8.5 may be startable from within Octave, because last time it showed that the original Arduino version did not start. Now let's see here for this hand. This is kind of working, and then I see that I have to adjust the oscilloscope a bit. Oh. Not quite sure what is going on here, but I don't quite like this. And I'll show you why. Because now I'm changing the look to this, and this is the signal. And pressing the button gives this. Well, you see the pulse modulation, but it is not a straight signal, and when connecting everything to ground you expect to have a very nice horizontal signal. Ouch. So I have to figure out how this is possible. Now everything is wired through, so if I take this one, put it here in the ground, and connect this one, even then I get a wrong very okay, now it's good again, and I have a nice signal. Anyway, up to a computer with Octave and attempts to get things working. Who knows? Right, so this is Octave, as you might know it. I have here the remainder of the installation procedure to upgrade instrument control from 130 to 131. You never know what difference it makes. Here it's still 130. Then I had to install the other IDE. So let's take a look at that one. Nope. Down, down, down. So this is the one I did install from Arduino. This is the one that I installed for Fedora, so that it just boots, just like that. And this is it, as simple as possible. But that's not the point. I need this one. Using this, and it says Arduino project will be created, etc, etc, and the Arduino IDE will open. That did not happen. So let's see if with this connected, because yes, it is connected by now. It's fully connected. Let's move it a bit up here. Better, nicer. Signal is now nice. There you see it. Let me move it a bit down. Right, so let's say Arduino set up. What happens? Oh, that makes a difference. Okay. That makes a huge difference. Let's investigate. Octave Arduino, yes. Core library, okay. I2C. SPI. And yes, this is about Arduino, which and from the other projects you know that I've used I2C and SPI. Okay, I can use a servo library. Servo from a motor. Shift register. Interesting. Rotary encoder. Also very interesting. Okay, so going back. I said here. Press the upload button. Okay. No, I need to be here. Am I connected? Yes, I am. Do I have all the rights? That I don't know yet. So, let's just press the upload button, see whatever happens. And the other program that I had, this one, will probably go void. Probably. Likely. Go. Okay. What's this about? Ah! I do not have the servo header file. Interesting. That means that I will have to install it most likely, but on the other hand, I thought I had a servo library. I will have to investigate this. Right, a quick search revealed that indeed there's a servo library, but that's not the only part, the only thing. Point is that the Octave, that the servo library that I use, I'm using for a different project, and I had to rename it in order to use it for the different project with this IDE. So right now I have to include the new library, search for servo, this is it. What is this? Well, the latest, of course. Install. And well, that was quick. I hope that works. So let's go. It uploads. Done uploading. I have to close this. I have to close this one. Opening this one again. And what does it say? Arduino should be closed. Yes. Next. Connecting. So now this would be the next step. I did it last time, but obviously failed. So let's try if this one works. If not, I have to use this one, because it is connected to the ACM0 interface. But let's try. Wow, that works. That made a huge difference. Next, well, this is it. Next, to skin to list the ports. Okay, let's do that. Okay, that's it. There's no more than that. Next. And from here I can do anything that I like, apparently. Get available pins, pin names. Let's do that. Interesting. Wow. Let's go forward. With A is analog input. These are the digital pins. Let's go backwards a bit. And 1 and 2 are, yeah, where are they? I assume, let's go here. So I assume D1 and D0 are here somewhere. And these are the A input, is that correct? Up to 15. Yeah, up to 15. And D up to 53. And 53 is right here. So from 0 somewhere. This is already 14, 15, etc. So it starts around here, 0 to 13, and then 14 up to 53. So it's all counted for. Very nice. And now I can program and use everything in a nice file. Putting things in matrices and put graphs, etc. The only thing is, of course, I cannot use this. Let's go back here. I cannot use this on my other project with the Arduino Uno that I use for more or less the same thing. At least I think I can't do that. And yeah, scientifically speaking, if you haven't tried, you don't know. So that's coming up in a different video. Interesting, but also it's very different because it is the Arduino Uno with partly Linux, and I have no clue if that is, no, that is not supported. True, that's not supported, because if I go up and no, previous, the Uno is not listed. Uno Mega2560, Uno I do have, Mega2560 I do have, the rest I don't have. So there are only 2 boards now that I can use. Even the Mega2560 that I have cannot be used. So the upcoming video for the Uno is not going to have this. Alright, what's next? Run something, create something, detect, okay, for instance, detect the button and have something to do with it. That is nice. How about sending something and detect with the oscilloscope, because that is what it's for. Let's go. So, looking at everything that I have now encountered in the manual for this setup, I have found that I can write a pulse width modulation duty cycle, and that is of course different than when programming with the Arduino IDE, because that automatically gives a pulse width modulated signal. Here I have to, just as with normal AVRC, indicate which pin. Well, this is an example for D5. So again, A is Arduino, and then write pulse width modulation duty cycle, and duty cycle is actually how much of that signal is high and how much is low. Half is that half the time is high. 1 is everything is high. So that is about the duty cycle. Going there, my wire is attached to pin 2, so it has to be D2, and let's start with this one. So AR is Arduino. Alright, pulse width modulation duty cycle to Arduino pin D2 for half. And now I am very curious what will happen on the oscilloscope. Oh, and by the way, on here as well. Will I be able to see it, or will it just be a flash? I am not sure. I do not know. Let's do this. Run. Save file, run. No. The other one. No. Go. Oh, F5 is run, but now I notice that I have to do something to get everything in place. How do I make this run for so much time? Okay, let me do this with everything off camera. Can I see something? Pressing F5. Well, the only thing that I can see is that this edged signal is disappearing is moving into a flat line when I press F5. And I'm not pressing this button. So I need to find out how to keep this going for some time. I think I know why, but with the for loop. With the range, but I'll have to find out. This is making things interesting. Alright, thanks to failed recording, I have to explain what I did. So, pressing the button with the wire here on that side of the circuit, I still only get 1/10 of a duty cycle. Well, not even 1/10, it's still 50%, which doesn't make sense. I broke the connection between this part of the circuit, so it's getting no backlash. This from the power is no longer going back. It's cut off. I rewired this part. So now this wire is coming here, another wire is going to the button, and the probe is going here. So nothing to do with this circuit anymore. This should work. But what happens, and this one should always get the signal straight from here. Now oh, this is interesting. This is interesting. Okay, let me change something. No, not that. No. I need, yeah, pulse, but I need a channel change. Okay, this is what I'm looking for, but still not correct, because I say 0.1 and not 50, and this is clearly 50. Half down, half up is 50. 0.5. This is 0.1. Doesn't make sense. Let me change this. And yes, I made a while true. Oh, this is not making any sense. While true. And probably end while, but let's see if that is it. I don't get an error. Do I get an error? Syntax error now. Yeah. So this will be then end while. Alright. Go. Oh, that was the problem. And I need an end while, and I had an end for. So then that doesn't execute. Let me see now whatever happens. Now I have 50%. No matter what. Alright. Now changing to 10%. Go. Here's no problem. So this is now 10%. Still not 10%. But I have no error here. Okay, going to full 100%. Go. Does it go? Yes. And if yeah, well, okay. Now to breakpoint. Run. I don't care. But it doesn't say run. Strange. Is it doing anything at all? Well, yes, it does, because this probe is receiving this signal. But this is not 100%. So how do I get 100% then? Well, through. Oh, I can do something different. Making it right into here and then go back. So for I is 0.1 to 1. Alright, so this means from 0.1 increase by 0.1 until 1. And then this. Alright. And then and 4. And then the other way around. 4. Then put it this way. 1. And then right duty cycle. J. Is it correct? Yeah. And another. And 4. Let's see what this brings. Yep, it's just running. That's good. Now I should see here something going on. Either fast or quick, but I'm not. What does this do? Nothing. That means that I am doing something wrong, but I have no clue what. So this is the final part of this episode with running Octave, running pulse modulation, but weird signaling for some reason. It's very well possible that I've made a massive error in Octave. Still have to find out and learn, but it's a start. Start to get the same thing in C as in Octave, or more appropriate vice versa. Nice learning experience, errors, etc. Thanks for watching. If you like this video, please subscribe to my channel, give the video a thumbs up and leave a comment or suggestion. You can also follow me via Instagram and Twitter. If you like what you see, then please support by making a small donation via PayPal, or if you don't want to do that, via Wired. More information on my website. You can also become a patron and have your name mentioned, depending on your pledge. More information is on my website, and everything is written under this video. This is of course to be continued. So once again, thank you for watching, and bye bye.